Okay, for the last part of our unit, we're going to talk about radicals. So first, let's talk about parts of a radical. So the nth root of a number a can be written as the radical expression, and you'll see it below. So let's take up all these parts. So this little root, this n, we call our index. This symbol here, this weird symbol, is our radical. Well, my pen doesn't want to write, but it'll come in just a minute, I'm sure. And then that A is called a radicand. Now, we don't really use, there we go, see, I said it would come in a minute. We don't really call it the radicand very often, but it is important to know that that's what it's called. Okay, so if there is no index, that is probably what you have seen before in life. So like you've seen like square root of 4, square root of 16. If there's no index, then it means that n equals 2. This means it's a square root. So if n equals 2, it's a square root. If it's 3, it's a cubic root, a cube root. So just keep that in mind, that index is an important part. If a radical has more than one root, the radical sign indicates only the principal or positive root. Okay, so the first thing we're going to talk about is perfect squares. So we're going to list the first perfect squares, the first 12 perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. It's really important to really have to know these, or to have them memorized would be the easiest, but to absolutely know them or have them somewhere near while you're doing these problems. So let's look at if we're given perfect square roots and we want to simplify them. So our first one is the square root of 16. Well, we know that 16 is just 4 squared. So if we take the square root of that, it's really undoing that perfect square. So the square root of 16 is 4. And then we have 1. If we have a value in front, you'll see this is being multiplied to the square root. So what we'll do is we're going to simplify our square root. The square root of 121 is 11. And so what this really is 2 times 11. And that answer is 22. All right, well, what if they're not perfect? Both of our examples were perfect square roots, easy things. What if they're not? So the first thing we're going to do is find the largest perfect square that the radicand is divisible by. So you're going to break down the radical into a perfect square, the largest one, and then something that's not a perfect square. And then step 2 is take the square root of the perfect square. Take it out of the radical. And then step 3 is leave the leftover under the radical symbol. So let's look at an example, the square root of 32. I like to break this up into a perfect square and something that's not. So 32, I know it can be divided by 4, which is a perfect square, but the other factor that is 8, and I know that 8 has another perfect square, which is 4. So I want to go larger than 4. And you'll see that 16 is a factor of 32. 16 times 2. So I write them like this as radicals because these both multiply to be the square root of 32. And then I'm going to take the square root of 16, which is 4. The square root of 2 I can't do anything with, so it stays there, and there is my simplified answer. This is the same thing as the square root of 32. All right, let's look at the square root of 175. Again, I know that 25 is a factor of this, but I want to go larger. I want to see as large as I can go. Oh, sorry, 25 is as large as we can go. I was going to try 125, but that doesn't work. So 25 is our largest one because 25 and 7. So I rewrite this as the square root of 25 and the square root of 7. I'm going to take the square root of 25, which is 5, and then there's my leftover 7. And so our answer is 5 and the square root of 7. All right, what about when we have a number in front? So remember, this just means that whatever we take out is going to get multiplied to 2. So let's first find factors of 54. So we have the square root of 9 and the square root of 6 will multiply to give us 54. And then remember, this is going to be also multiplied times 2. So we take the square root of 9, which is 3, and then our leftover. And then let's go ahead and multiply these whole numbers. 2 times 3 is 6, and we still have that square root of 6. And so there's our simplified answer. All right, let's do our last example. Here's that -5. So whatever we take out of 150 is going to get multiplied to -5. So factors of 150, we're looking at the square root of 25, the square root of 6, and that's, remember, going to get multiplied times -5. So the square root of 25 is 5. And then let's do -5 times 5, which is -25. And then our leftover 6. So our answer is -25 and the square root of 6. We can also simplify with perfect cubes. So it's kind of the same thing, but with perfect cubes. So let's look at our first 10 perfect cubes. 1 cubed is 1. My pen is acting funny right now. Okay, 1 cubed is 1. 2 cubed is 8. 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. All right, using that, we're going to simplify these perfect cube roots. So the cube root of 8, we already said, is 2. So our answer is 2. These can be negative. Your square roots cannot be negative because there's no negative times a negative that will equal a negative. But a negative times a negative times a negative will equal a negative. So if we look at the cube root of -27, then we know our answer is going to be negative. And then we're just looking at the cube root of 27, which we know is 3. So our answer here would be -3. All right, let's look at this one. We have 5. Remember, whatever the cube root of 343 is, we're going to multiply that times 5. And then we can see that the cube root of 343 is 7. And that means that our answer is 35. 5 times 7. All right, on this next one, whatever the cube root of 1,000 is, of -1,000, and remember our answer is going to be negative, so let's go ahead and write that. And we're going to multiply it times 2. So the cube root of 1,000 is 10. So we have 2 times -10, and that gives us -20. All right. Again, we can simplify non-perfect cube roots using the same methods we used to simplify square roots. So we're just going to break down this radical. We're going to remember to multiply times anything on the outside. And we're also going to remember that if it's negative, that we have to take that negative square root out. Or cube root. So let's look at the cube root of 40. This has factors. We know 8 is a perfect cube, and 5 is kind of the leftover. So we take the cube root of 8, that gives us 2, and then we have our leftovers. So the cube root of 5. So it's 2 and the cube root of 5. On this next one, whatever we take out, we're going to multiply times 2. 430, the cube root of 432. 216 is a factor, so the cube root of 216 times 2, the cube root of 2. The cube root of 216 is, let's see, 1, 2, 6. So we have 2 times 6 times the cube root of 2. And that means our answer is 12 and the cube root of 12. Cube root of 2. Oof, tongue twister. All right, let's look at the next one. So we have a negative cube root. So remember that means that we're going to take out a negative. But look at this. We have a negative 2 already outside. So when we take out that perfect cube root, remember it's me a negative times a negative. Keep that in mind. All right, so let's look at this. We have negative 2 times, let's go the cube root of negative 125 and times the cube root of 2. So we go ahead and take the cube root of negative 125, which is 5. So negative 2 times negative 5, and then our leftover cube root of 2. So negative 2 times negative 5 is 10, and then we have the cube root of 2 because a negative times a negative makes a positive. All right, on this next one, we have a negative 3 on the outside, and we don't have a negative in our radical, which means our answer is going to be negative. So factors of 189, we have 27 and 7. So the cube root of 27 times the cube root of 7. So then we'll have negative 3 times the cube root of 27 is 3. And then our leftovers. And so our answer will be negative 9 and the cube root of 7.